So today I'm just teaching you how to graph by picking values for x and then making a graph. There are other ways to graph, and we'll learn some of those along the line here. So one way to get the graph of a quadratic function is picking x values, but you will find that I'm going to pick them for you because I know good ones to choose that will give you the actual U-shaped graph rather than just part of it, like one of the arms, and doesn't even show you maybe where it makes its turn or anything. So I will pick your x values for you for a while here, and then we will use them to find values for y. We need some ordered pairs, some points to put on a graph to help us get to that quadratic function. Okay? So we need to pick x values, we meaning Mrs. Legrand for now. We're going to put them into the function and get values for y so that we get some ordered pairs, some points for our graph. There isn't any number on the number line that you can't put into a quadratic function and actually work with it. In other words, you can square any number on the number line, including 0. You can square a positive number, you can square a negative number, you can square 0. So we say that you can pick any value you want for x. So when I'm trying to choose values for x for you, I'm saying I can pick them from anywhere on the number line. And remember, the x values make up the domain. We talked about domain and range when we talked about linear functions. So all the x values make up the domain of a quadratic function. And so it is all real numbers. So when we talk about the domain of a quadratic function, it will always be all real numbers. Because there's not a number on the number line. You can't put it into a quadratic function and square it. Or also multiply by something when you talk about like the bx term. But then the y value, that's a little pickier. In other words, the y value is dependent upon the chosen x value. So therefore the range, remember the range is made up of y values. The range actually has a restriction. And it should make sense that the range has a restriction because we know in the graph that graph starts making it's going along and then all of a sudden it turns. It stops and says, I'm turning right here and I'm going back the other direction. So it's going down to a certain y value and then it stops, makes a turn and goes back up. So all those y values below it don't get included. Or if it's an upside down one, it starts climbing up and getting all those y values, and then all of a sudden it stops and it says, I'm going to turn and go back the other direction. So all those y values above are not included, just those ones up to that point are included because now the behavior goes back the other way. So our range is going to have like a restriction on it. So our range is either going to begin at that minimum, because remember the minimum is the y value of the vertex when the parabola opens up. So remember, this is when let's draw that little picture there in fact. When we have a parabola that is opening up, the y value is the y value of that vertex is called the minimum. In other words, the ordered pairs, none of the y's will go any lower than that. Or the range will begin at the maximum. Because now we have a parabola that is opening down, and where it makes its turn at that vertex at the top, we can't get any higher than that maximum. The y values are not going to go any higher than that. So we have a restriction on our range. We have to think harder when we talk about the range. We get to be like this about the domain. The domain is always going to be all real numbers for a quadratic function. We don't ever have to worry about it being something different. Okay, so here I say use the given table to graph the function, then state the domain and range. So here's our function, y equals 1/2 x squared. Is that in standard form? Yeah, y is by itself, and we have a 1/2 x squared. So in this case, it's already in standard form, so we don't have to put it in standard form. Tell me, without us writing it down, what's the a value of that quadratic function? What's our a value? 1/2. So what does that tell us about if a equals 1/2? When we're done graphing this, let's take a moment and just write that down. If a equals 1/2, what does that tell us about how it's going to open? It better do what? It better open up. Yeah, because it's a positive number. So when we're done graphing this, if we don't have a u that opens up, there's trouble. Okay, so I've chosen some x values for you so that we'll get a good graph. When we graph a quadratic function, we always use a minimum of 5 points. Sometimes we even use more than 5. So this time I picked 5 x values, so we're going with the minimum amount of them. And we're going to substitute our x value into the function and get our y value. So 1/2 times -4, and that -4 has to be squared. What comes first in order of operations? Would we take half of -4 first?
No.
Or would we square that -4 first? We need to square that -4 first, don't we? So we're going to say, okay, well, 1/2 of what? What is -4 squared? -16. -16?
Positive.
Okay, a negative times a negative is a positive, and 4 times 4 is 16. So half of positive 16, and half of positive 16 is 8. Okay, so let's go back over here because I've used up all my room. We actually have now found an ordered pair for our graph. What is that ordered pair?
-8, 4. -4.
How about -4?
What did I
8.
say?
You said -8, 4. -4, 8. So we'll plot our points after we find all of them, okay? Okay, so now we're going to substitute in -2. So half of -2 squared. Those parentheses are really important. They're actually playing 2 roles here. They're showing multiplication, and they're showing that we have a negative number being squared. So half of what? What's -2 squared? 4. And half of 4 is 2. Now, you cannot be successful with graphing quadratic functions if you don't take time here to process this substituting in and getting your y value correctly. So you want to take the time here to make sure that you're getting good y values. Okay, next we will substitute in the 0. Well, 0 squared is 0. And half of 0 is 0. Yeah. Whenever there's multiplication going on with zeros, we end up with zeros. Now, the only reason, don't think though that for every quadratic function, when x is equal to 0, the y will always be equal to 0. Don't go there. This time it's 0 because there's no c value, because c is 0. That's the only reason it turns out like that. Okay, and then now we will do +2. Squaring +2 is the same as squaring -2, isn't it? So +2 squared becomes 4, and then half of 4 is 2. So we have ordered paired +2, +2. Anybody want to predict what they think the next y value is going to be if you haven't done it yet? I just want, what do you predict the next y value is going to be? Probably going to be 8. Yeah, the y value is probably ordered pair. Because why? Can you see what's happening here? Right here. It was 8, then it was 2, and then it was 0. Now it bounced back to 2. Do you think it's made its turn? Yeah, it's made its turn and it's bouncing back up. So chances are, what we get for this last one is probably going to be 8. So let's see if that works out. Half of +4 squared, which is half of 16, and half of 16 is positive 8. Okay, go ahead and put those 5 points on your coordinate plane on your graph.
I'm confused as when I graphed it already.
You already graphed it?
Yeah,
It didn't go well?
it's sideways.
Mine turned out good.
I don't know if I'm doing this wrong or what.
Okay. Jesse, are you done graphing yours?
I think
Yeah,
I
but
forgot the domain
Cassie,
remainder.
I know what I
think you found it?
Yeah, I looked at the X and Y wrong. Alright. Figure it out. Yes, I really do that.
Now, quadratic functions are not B's, they are U's. B's have nice straight, sides. U's have nice smooth curve to them. So we never use a straight edge to draw a quadratic function. We never just connect the dots with a jag and say, okay, line segment from one dot to the next and then another line segment. We do a nice smooth curve, and this is the trick about drawing the curve from. You have to figure out what way works best for you. Does it work best for you to start down at the vertex and draw up like that, and then do the same thing coming from the other side? Or can you make one whole smooth curve at one time without lifting your pencil? Make a nice U, but it's really a smooth curve. There should be no stopping and lifting your pencil and making line segments. Now I'm feeling pretty good about this because we said it should open up, and it is, isn't it? Okay, now we have to identify the domain and the range. What's the domain? What did it say up above? All real numbers. It's always going to be all real numbers, you guys. The domain, x can be anything we want. X can be anything we want. We could keep picking x values going out both the other directions, and this would just keep climbing and climbing and climbing and getting a little wider each time as it climbs, but it's going to just keep going. So we do take care of all the, and I'll give you a little abbreviation for, let's write this word, let's write the words though first, but then I'll show you a little abbreviated symbol, math symbol you can use for all real numbers. So all real numbers is our domain. And anybody think they know what that symbol is for all real numbers?
I'm pretty sure.
ARN.
It's a capital R, but it has a double side over there. So it's capital R with a double thickness wall on the left. So you can use that to mean all real numbers. Okay, now the range. Is the range going to be all real numbers?
No.
No. There are points on that curve where there are some y values that are not covered. Does this graph, this quadratic function have a minimum or a maximum?
Minimum.
As a minimum. That means the y values are going to not go any lower than the y value of that vertex. What is the minimum in this one? 0. So since the minimum, you know what, and I think that might be good for us to write down in our notes. The minimum is 0. You can't go any lower than that. That's what minimum means. You can't go any lower than that. So we're going to say y, because remember the range is made up of y's. Y can't go any lower than 0. What would we put for an inequality symbol?
Y less than.
Can't be any less than, it can't be lower than 0. So doesn't it have to be greater than or equal to 0? There's our range right there. Y is greater than.
Oh, we have to use these signs again.
These inequality symbols just never go away, do they? So y is greater than or equal to 0. None of the points on that curve, even the ones we didn't find, none of the points on that curve will have a y value less than 0. They're all going to be 0 or higher. And that should make sense when you look at it. All the y values of all these points should be 0 or above. Okay, questions? Okay, then let's go to the back side.
I have a question for like these ones right here.
Uh-huh.
Like if one that x is already a negative and it has a negative x in the equation, does it just stay negative?
And negative stays there. It's not part of your substitution, but it's there.
But then like for the bottom ones where they're positive. Well,
Okay, so let's first of all, let's decide when we're done graphing this, should it open up or should it open down? What's our A value?
-1.
-1.
Open down.
It should open down then because we have a negative. So when we're all done, it should open down. And it should be what shape?
U.
A U. It better be a U-shaped graph.
I ran into a problem.
You ran into a problem, yeah. I figured that might happen. Okay, again, I chose X values for you, but this time I chose 7 of them. And we're going to substitute for the X. We're going to substitute for the X. So negative is there. That negative sign is not part of the X. Now we substitute in for the X, -3. We square it, add 1. So now we say, what comes first? Well, we do that exponent first. So that negative sign that's not part of the squaring is still there. What's -3 times itself? Negative times the negative is always a positive, so that'll be +9. So that -3 squared, this is the negative right here. This negative that's here is that negative, okay?
That's what confused me.
Yeah. So that negative sign is not part of the X. It's part of the function. And now we have to add that 1. So -9 plus 1 is? -8. So we have ordered pair. Now we have some room over here. -3, -8. Okay, following that same thought process. That negative sign is not part of the X. So we have to write it down, substitute -2 in for X. That negative sign just keeps tagging along for a bit here. We say negative. I'm only going to deal with the -2 squared part right now. What's -2 squared? Not negative.
No, 4.
+4, and then it gets attached, it comes behind that negative sign, doesn't it? And then we have +1. And -4 plus 1 is? -3. So now we have ordered pair -2, -3. Okay. Now we got -1 to do. Negative, and then -1 substituted in for X. That negative sign is tagging along. -1 squared is +1. And -1 plus 1 is 0. So we have ordered pair -1, 0. Do I need to clarify anything for anybody yet in this problem? Those of you who were doing it wrong, you figured it out? My worker aheaders?
I'm just stuck on this one.
Okay, so -0 squared. 0 squared is
0.
0. Well, that negative sign's tagging along though.
Why is that negative? Or 0 can't be a negative.
Just be careful. Remember, we can also say something. What else can we say with that
Wouldn't
negative
it be
sign?
1?
We can say the opposite of. What's the opposite of 0? 0. So it's really going to just become 0. It's okay. In other words, you can't, we don't really talk about 0 being negative, so instead what we say is, oh, but the negative sign can also be read as the opposite of, so the opposite of 0 is 0, and 0 plus 1 is 1. So we have ordered pair 0, 1. Has it made its turn yet?
No.
Are there any y values repeated yet? That's when we know it's made its turn. Is when there's been a y value repeated. Well, that hasn't happened yet, has it? Okay, so let's go do positive 1. So the negative sign comes along again, but we substitute positive 1 in this time. What's positive 1 squared? Yeah, so the negative sign that's coming along, 1 squared is 1. And negative 1 plus 1 is 0. So now we have ordered pair 1, 0. What just happened? It made its turn. Where did it make its turn at? What do you think? Where do you think it might have made its turn at? Which point?
0, 1.
Yeah, 0, 1. 0, 1 is where it made its point. Its turn. There's not going to be another y value of 1, but now we're going to start repeating all those other y values. Okay, so negative, the tag along, and 2 squared is 4 to get attached to that tag along negative, and we end up with negative 3. So we have ordered pair 2, negative 3. Positive 2, negative 3. Well, I'll let you off the hook here. I'll make sure the work for the last one of those of you who aren't ahead of me. Well, those of you who are, it's done anyway, right? Okay, what's the last ordered pair going to be?
3 negative 8.
3 negative 8. Because the x value is 3, we have this repeated pattern going on here. We see that the next, so there was 0 repeated, then the negative 3 repeated, and now we're figuring, okay, the negative 8 has to repeat. Okay, get those graphed, and hopefully you will have a u that's opening upside down. Negative 3. Okay, I got a problem here.
Does it say minus?
Yeah, I grabbed my first point wrong. Negative 3, negative 8. Where's that it made its turn in? Was it 0, 1? Okay. And again, you'll learn which way works best for you. I tend not to do very well in all one stroke, so I usually divide it up into 2.
Yeah, I'm not going to do it
Hey, what's the domain in this one? Don't think so hard!
Maximum. All real numbers.
No, all real numbers. Remember, the domain is always going to be all real numbers for a quadratic function. All real numbers. And the range. Well, does this one have a minimum or a maximum?
Maximum.
A maximum. What is its maximum?
Y is less than or equal to 0.
Maximum of 1. Okay, so then that would mean y is, it doesn't go any higher than that.
Less than or equal to.
Less than or equal to 1. There we go. Isn't this fun?
Well, now that I understand it, I don't